So angle similarity told us that if we could show two angles in each triangle are the same, then we could say that the two triangles are similar. Our second one was side angle side similarity. Side angle side, much like congruency, we had to know that the angle in between two sides were congruent and that the ratio of the two sides was the same. And lastly, we had our side-side-side similarity. Where you had to show that all three corresponding sides had the same ratio in order to be similar. All of these involved us having to we did a lot of cross multiplying in this unit. So to reminder on how to cross multiply, if you had A over B equals C over D, you would multiply across and get B times C equals multiply across A times D. Okay, in this unit we also had something called the side splitter theorem. That let us set up an equation. Whoops, let's make one of these an X. That let us set up a proportion because these two sides are parallel. You can set up the proportion of this part over this 5 over 6, so part over part equals x over 10. If we didn't know that these were parallel, we would have had to do 5 over the entire length equals x over the entire length. So this is a special situation where we could set up a proportion if it's the two sides that are being split. If it wasn't two sides being split, so if it looked more like this here, we could not use the side splitter theorem. We would have to do this little part x over the whole part A equals the smaller part y over the larger part b. So make sure you know the difference when you can do this way and when you would need to do this way. This is pretty much how it'll happen no matter what. This is a special case. So even if you didn't remember this theorem, you could have set this up as 5 over 11 equals x over x plus 10, and you still would have gotten the same answer. So you could still do part over whole if that's easier for you to remember just the one way. Let's see, I feel like there was one more thing we did in this unit. Oh, yes. We also did, when we have a triangle, and we have the angle bisector, I believe. It divides our sides proportional. So we could say A over B equals C over D. And that was Unit 6. So unit 6 was about similarity and setting up a proportion that you can cross multiply and solve for. So it was a lot of setting up the part over the whole or part over whole and setting them equal so that you could cross multiply. We also did scale factors in this unit. Do you guys remember what a scale factor is?
Yeah.
What is it?
It's when there's like two triangles and like one smaller or bigger, it would be like new something. I don't know.
Okay, your scale factor is always new over old. So when you are trying to figure out a scale factor, you take the length of your new figure and compare it to the length of your old. Okay, we also did dilations in this unit. That was the other part of it. So in terms of what you want to make sure you know for this unit is you really want to make sure you understand what similarity is and that you know how to set up your proportions. Because that's going to be the bulk of it. You do have a couple that are like these where you have to set up from a triangle, but it's mostly going to be your similarity postulates and setting up the right proportions. Okay? There won't be any dilations on your final. Doesn't mean there won't be any scale factors, you're just not going to actually have to draw any dilations. Okay? So any questions you have in regards to Unit 6?